I'm from Algarve, from the Medical Imaging Department of the University of Algarve, and this investigation has the main purpose to assess the viability of bismuth breast shield in thorax CT scans to determine the percentage of dose reduction and to evaluate the image quality. For that, it were made 135 measurements in a 16-slice CT scanner without protection, with the phantom and with the protection, with the protection and with a 1 centimeter sponge, with protection and with 2 sponges, and with the bismuth protection attached to the gantry. Those measurements were performed on a phantom with an ionization chamber using the routine thorax CT and the constant variables. Image quality controls tests were performed using a Gammex 464 phantom, and this phantom has 4 modules. For the module 1, it evaluates the alignment, the positioning and the accuracy of the Hounsfield values. For module 2, the low contrast resolution. For module 3, the uniformity of the Hounsfield units values. And in the module 4, the high contrast resolution in the pair of lines 4 millimeters. For the results, it was evaluated the dose rating for the routine thorax CT protocol, focusing only in the comparison the dose received by the phantom in that configurations. And as we can see, the better configuration, it was with the protection coupled to the gantry, because it was at 22.2 reduction of the dose. In the image quality control, the evaluation of them, it was made by a comparison of the image obtained without the protection and with the protection in that different configurations. So in the module 1, as we can see, this is the reference, and for acrylic, water, air and polyethylene, the results were not within the range, only the bone was in the range. For module 2, the contrast to noise ratio, the values were 1.2 without protection, 1.1 with protection and with a sponge, and 0.7 with protection coupled to the gantry window. For module 3, with the protection on the phantom, with and without sponge, there was no uniformity of the ROIs from the periphery to the center, but with the protection coupled to the gantry, the values of the peripheric ROIs were in the tolerance range, but not the central ROI. And in the module 4, we know that the reference is 5 line pairs 4 millimeter in the thorax, and in all configurations we identified 7 line pairs or 9 line pairs using different kernels. For conclusion, the configuration with protection coupled to the gantry was the most accepted in this study. It was also verified that minimized the strict effects when compared with the other configurations. Regarding the dose measurement, we obtained a reduction of 28.2% in the phantom, and we now know that it's appropriate to implement this protection configuration coupled to the gantry as a protective measure of patients in thorax CT scans. This is our reference. Thank you for your attention.